Hello and welcome to the Engerati studio here at European Utility Week. Tail end of the show. So Steve,
happy to bring up the end of the.
Thank you for making the time to be here. And AES do a lot of things. Your particular specialism is on the energy storage side of things. We're going to keep the theme around grid scale and energy storage. And one of the things it seems to me that in the US we're getting to larger and larger installations. Mm-hmm. That whole pilot phase seems to have been done and dusted, but I still kind of feel in Europe we're still kind of dabbling around in the pilot area. I mean, is that what you would say?
Well, maybe just to set the table for a minute. I mean, we did our pilots at AES 8-9 years ago. We found out how to make it work. We tested it at the grid level. Mm-hmm. And ever since then, we've put in 86 or so megawatts of installations in 2 countries, and we're aiming to put in several more. And we haven't found it to be in a pilot phase ever since 8 years ago. In Europe, we're building 2 plants, one in the Netherlands, one in Northern Ireland, that'll be completed. They're literally being commissioned starting next week. They'll be completed and making real money in December, January period, and
you don't see the problem.
I don't see the problem. Right. They're a little bit on the small side. They're only 10 megawatts, 20 megawatt resource. But in the case of Northern Ireland, we're looking to that to be the first 10 of 100 interconnect, 200 resource. And in the case of the Netherlands, we're looking to already at expansion options there.
And we're talking a little bit off air about the economics of it, of these plants. Can you just talk us through a little bit? I mean, are there fundamental differences? Well,
the 2 models that we've been successful at as business people. One is in Chile, and that's all it is replacing batteries for required reserves so that the required reserves can go back up and operate where the plant is most efficient and sell those megawatts into the system. The other application has been in the US, in the fast frequency market, which I think you're familiar with, where you sit there and balance the grid. That's the same application. Both of those, by the way, are profitable. They're commercial. We've led the way into PJM where others are following in now because they recognize there's money there, money to be made. And same goes in Europe to the extent there's a market. Where we've found a market is in the Netherlands. It has access to a weekly PCR, primary frequency control auction, that has a reach into not only Netherlands but also into Germany, Austria, and Switzerland, and we built our business case around competing profitably.
And being able to access those markets.
Exactly. Now, I understand that those aren't available throughout Europe yet. My guess is that over time, as companies and utilities and regulators recognize the value that's provided with these fast frequency provisions, it will expand fairly rapidly.
And when we were talking off air, it was quite interesting for you to use the phrase, because we've been following this for a while, and we did a panel here when the show was in Amsterdam, and people were still talking about use cases and different technologies. I think kind of batteries are the one at the moment. But the other thing that people were talking about is the scale side of things, and you used the phrase off air. It's like we believe the potential is to compete with pumped hydro in terms of that. That's pretty phenomenal. Either that panel was way off the mark, or we've moved along from a tech point of view.
And maybe that's one of the reasons that we've been profitable, is we've focused on scale. And obviously, the more scale you have, the more buying power you have. Our system, our Advancion system, pre-qualifies suppliers to our particular specification. So if someone wants a project, we can get the best then price of batteries from this multitude of suppliers and have those start shipping on a boat in literally weeks and have the project built within a year. It's all scalable. So just as we do that in a 10, 20 megawatt operation. We could do it in 100, 200 megawatt operation. We've recently done an analysis of longer duration applications like, as you mentioned, pumped hydro, and we find it exceptionally attractive for a number of reasons. One, a pumped hydro facility takes many years to develop. It gets over all the politics and the environmental issues, et cetera, and then once it's developed and goes into construction, presumably you have to call on that for the next 30, 40 years. With energy storage, you can scale 100 megawatts in a year at this location to provide the same pump storage benefit, actually faster than pump storage. You can put another 100 megawatts some other location in a village, in a city, in an urban area, another 100 megawatts 3 years later, so you can scale it. And the benefit of scaling is, again, it's volume, drives price, drives more volume, drives more price.
And you can scale it and localize it, can't you? Because
you can put it where it's most needed. In the case of pumped hydro, you're looking for an ideal reservoir with some altitude so you can have the pumping action going between both directions. But once you develop that, you're stuck. I mean, you have pumped hydro in a location, yeah, you don't exactly move it. Yeah. Whereas here, you can distribute 100 megawatts there, 200 megawatts here, and you can scale it. So we're excited about that.
So when I talk to someone like you about grid scale storage, and I got that sense already off air, and it's coming through now, is where you're looking at it, and you go, you almost give off a sense that I don't see the problem, you know. And so one of the questions I want to ask is, okay, you know, why are we still talking about it? Because the other side of the equation, which, you know, you see it in Germany with the Energiewende and so on. There's all this renewable energy. It needs to be stored somewhere. But I get a sense that actually, if we plan things out correctly, we could have a pretty balanced grid. The technology to do that is already there. So what's missing? Is it the distribution network? Is it the control mechanisms?
I think some of it's the mindset, because I'm familiar. There was a peaking RFP that went out a couple of years ago in Europe, and it specifically said we want natural gas peaking generation, without considering, well, maybe there are other peaking applications, but people weren't really thinking about battery-based storage as being one of those. We've proven through our 20-year PPA that we just recently signed with Southern California Edison, we're going to provide 4 hours of flexible peaking capacity that Southern Cal Edison can use whenever it wants, and we're on the hook to make sure that 100 megawatts is as good as on the last day of year 20 as it is the first day of year 1. That's our responsibility. And to be competitive with peaking is one of the nuances, one of the educational points that is necessary. The other one is, you brought up the pumped hydro application. I don't think the average person that's looking at 1 and 2 megawatt pilots can really fathom a 500 or 600 megawatt pumped hydro storage alternative that is based on batteries. But we've done the economics, we've looked at the cost benefit, and it can work.
And what's interesting about the California is, you know, it's done on a sort of PPA arrangement, and you're within your rights to correct me, but I've seen very little of that type of model being looked at, or maybe it's in the process, but I've certainly not heard of it.
No, and you're right, and that brings up in mind another, I guess you'd call it an impediment to using fast reacting storage more broadly in Europe, and that is the setup, the regulation. Never really considered battery storage as being a real source of both energy.
It's a power generator, isn't it?
Yeah.
If you look at it, you know, you can look at it as a sink, but
right, exactly.
it's also a power generator.
That's what's significantly powerful, because in a pumped hydro, you can slow down the pumping or stop the pumping. You can slow down or stop the water flow, but a battery can do both of those within less than a second in each direction. So the regulation, I think, in Europe needs to kind of identify these issues. It can either provide auctions for peaking applications, fast frequency response, that type of thing. It can encourage ownership. I understand the 20-year PPA obviously is not a popular thing in Europe, so I'm not suggesting that is the only alternative. But if you look at how do we save consumers money by deploying more fast-acting battery-based storage in a variety of applications, how can we do that from a legislative regulatory framework and work from that direction that you're saving consumers money? Then that's the coup de grace.
Because you know, when you look at that model, because it's quite an interesting model, and you know, it's a different use case, but I think the mechanics are similar. If you look at what South Africa have done with their PPA regime, and that's around renewables, right? So things like that. But again, it's immensely replicable, because you know, one of the things that's frustrating when you hear about market issues and instability issues, and okay, some of them are due to the market, but some of them are also due to the laws of physics, that, you know, wind blows when it wants to and sun shines when it wants to. It seems to me insane that we aren't moving towards some sort of market that actually looks at storage in the right light, not just a sink, but something that does something on it.
And I mean, if you walk down the street and took a poll, I mean, of everybody say yay if you like renewables, I mean, everybody gets that. They see renewables can change the world, so to speak. But the only thing stopping us from just going and taking the ceilings off renewables is having a way to balance the system. And I can't think of a better way to balance the system than to deploy battery fast-acting storage, whether it's on a decentralized matter or in a decentralized matter or on a grid level. It raises that level of penetration of renewables that everybody's looking for, because it's clean and it saves consumers money.
And to use an analogy on from the tech world, as we kind of coming to the end of our time, is it seems to me that my observation is that the more we scale this up, the more we then look at making the battery manufacturers do their R&D, and all these new materials are coming in that, you know, with these sort of environments, if the control system is right, you've got an opportunity to swap out new technologies.
Exactly.
I mean, there's zinc air, there's all these different things coming into play.
Well, internally, we're really excited because our 4th generation of our proprietary software and solution called Advancion just got Warrior Run, our Virginia, Maryland product up and running, and now we're going to be able to offer that outside of AES to other parties. And the beauty of it is open source. So if lithium ion turns into some other alternative that's better, we swap out the batteries. If no longer you need fast-acting storage or peaking, you have some other application, you change out the front end of that with the software. So we're set up to deal with whatever happens down the future. Whereas if you build a nuclear plant, you build a new pumped hydro storage project, you build a new gas or coal plant, you've pretty much made that commitment to that technology, to that location for you name it, 30 years, I guess, in most models.
I come from the UK. We've just done a deal on nuclear where, you know,
that's a whole nother.
That's a whole different discussion.
Story, yeah.
Okay. Well, Steve, thank you very much for joining us. Thank you for giving us an insight in the narrative. We wanted to explore that because we really think that on the network that the whole grid scale storage hasn't quite been reported and looked at in the right way in Europe. So thank you for taking the time.
Thank you, and I'd encourage any of your readership, your viewership, to the extent that you want to come and see a real live working example of energy storage in Europe. We'll have our units ready to be viewed early next year, January, February.
So those are the ones in Amsterdam and in Northern Ireland?
They're actually in southern Netherlands, in the Zeeland province.
Okay.
Yes, is one, and then in Northern Ireland, north of Belfast.
Connect with Steve online, take a trip to Zeeland and Northern Ireland. There we go.
Thank you.
You're now a tour operator.